Okay, so as in the last video, we have discussed about Born-Haber cycle in very detail, right? We took an example of NaCl, and then we initially took them in their stable state, which means Na was stable in the solid state, and Cl was stable in gaseous state. So we took them in their stable state. We made them react together, right? And the compound was produced. Along with that compound, heat of formation, the energy was released, right? And that what we call the heat of formation. And then we need to calculate the lattice energy, right? In order to calculate the lattice energy, we have already discussed lattice energy is nothing but it is the energy which is produced along with the 1 mole of ionic compound when that is produced by the reactants in the gaseous form. Reactants in the gaseous form. See, so these were reactants in the gaseous form, and in this case the energy which was produced was lattice energy. Today we are going to look at another example which is about MgF2, right? So we are gonna make the Born-Haber cycle of that as well. So we know that we are going to react Mg with F2. MgF2 plus heat of formation, right? Wait. Now see, we have taken here Mg and fluorine. Wait. Yeah. So we have taken Mg in its stable state, and Mg's stable state is in the solid form, right? Mg is found stable in the solid form, and fluorine is found stable in the gaseous form, right? So we have taken here reactants in their stable form. That's why here the energy which is released is heat of formation. But yeah, we need to find the lattice energy, right? Because Born-Haber cycle is used to calculate the lattice energy only, right? So initially we need to convert this Mg solid one into Mg gaseous form, right? In order to make it into gaseous form, Mg gaseous form, we need to give it energy, right? We need to give energy to this, and this energy would be heat of sublimation, right? Heat of sublimation. Right? Now we need to remove the electron from it, right? We need to remove electron from it in order to make it Mg plus first. Initially we'll be making it Mg plus, then Mg double plus, because we know that Mg will gonna lose 2 electrons. Its electrovalency is 2, right? Now Mg will lose 1 electron. Now required to remove an electron from the gaseous ion is ionization energy. So here we're gonna give ionization energy, right? Now we need to make it double positive, right? Mg plus plus in the gaseous form. So this is second ionization energy. Second ionization energy, right? Now we need to break the bond between fluorine and fluorine first, right? We know that fluorine, there is a bond between these two fluorines atom, right? We need to break the bond first, right? To break the bond means to make this 2F, this FF bond would be broken, right? Then there would be 2Fs, so 2F. In order to make the bond between these two fluorine atoms, we need to give energy of dissociation. energy of dissociation, right? Then we need to make it gain the electron, right? Gain the electron. And when it will gonna gain the electron, the energy which is released, when an electron is added to the valence shell of the gaseous ion, that is known as electron affinity. Right? Now see, this and this, Mg double positive in the gaseous form plus 2F negative in the gaseous form will both gonna react together to form MgF2 plus lattice energy. 1 mole of MgF2, and of course if 1 mole of ionic compound is formed, the energy which is released with it is lattice energy, right? So this is how you can find the lattice energy, by Born-Haber process or Born-Haber cycle. So this was all for today.